All right, everyone, I believe we're going to go ahead and get started. Thank you very much for your attendance. I wanted to introduce the title of this month's webinar, Antiviral Air Quality in the Age of COVID-19. So first, let me give you some information about PureAir filtration. In case you're not familiar, PureAir was founded in 2004. We specialize initially in the removal of gases, odors, vapors, and other toxic gases. Our systems are used to protect sensitive electronics and machinery at industrial sites, preserve precious works of art, and protect people from accidental toxic gases, and improve air by removing odors and pollutants. So our focus has always been to protect people against hazards. And recently, PureAir has expanded its expertise into air filtration to support the antimicrobial indoor air quality market. And that's the subject of our discussion today. I'm Kevin Jameson. I'm president and founder of PureAir Filtration, 21 years experience in the filtration market. I have a bachelor's and master's degree in engineering from Georgia Tech in Atlanta, Georgia. I'm an ASHRAE member, and I am a committee member for the WEF Odors and Air Pollutants Committee for the Environment Federation. So everyone has, of course, the world is on the edge of its seat in regard to learning information about our current pandemic. And hopefully this information, we've all learned a lot of information. Hopefully this will provide some additional information here. But one of the keys that we need to understand is really how small viruses are. So I found this very nice illustration indicating relative size of some microbials. So this is let me get my laser pointer on. This is a bacterium here. So of course, we know that bacteria are very, very, very small. This one happens to look large on here. But if you go through the size of this is about 2 micrometers, all right? If we go down the scale to the size of viruses, we come to sizes of typically around 20 to 50, and for some large viruses in the area of 120 to nanometers. So entire huge scale portions, far, far smaller. Now, PureAir, fortunately, is in the business of removing molecules, which are actually far smaller than viruses. And so, fortunately, our expertise comes with some background on removing extremely small particles, individual molecules, relative to viruses and small particles. So, just to give you that feel. So, important information to understand, the protective capabilities offered by an N95 mask. I think everybody in the world now knows what an N95 mask is, but of course they understand that that's the best protection, best personal protected device that you can have readily available. These masks have the ability to capture 95% of particles that with an average diameter of 300 nanometers. So everything from this side over is not generally caught inside an N95 mask here. So that's the difficulty in trying to understand how an N95 mask is still the best technology that's out there, but this is basically the cutoff between what an N95 mask will capture and what it won't capture. So the SARS-CoV-2 virus, which is the actual name of the virus which causes the disease COVID-19, is about 60 to 140 nanometers in size. So we're talking about this range right in here for the SARS-CoV-2 virus. So I just wanted to start off with just giving everyone a little perspective about the difficulty of specifically individual viruses and such. And there's, of course, a lot of discussion, a lot of differences and of opinions about how to catch particles and whether it's necessary to be concerned about particles this size. But just wanted to start off with everyone just understanding the relative nature of this. So jumping into indoor air quality, if you took a look at the indoor air quality market, the field, prior to COVID-19, you'd basically take a look, you'd basically qualify it that it was historically focused on particulate and gaseous pollution, dust, and to some extent, gases. And in fact, gases were fairly new to the indoor air quality market, relatively new. Over the past 20 years, it had become a focus. There's very, very little focus on microbiology in air quality. Typically, the technology is focused on pressing for higher efficiency dust filters, using adsorbent filters to catch gases, harmful gases, and providing more fresh air, the concept of bringing in more fresh air into a building. Really, microbes were only a focus for the healthcare environment, a very, very specific market to take a look at, and generally was not a concern for the general public. So the primary three legs of this stool were particulate filtration, gaseous filtration of some sort, and then bringing in outside air. And of course, there's challenges for all of that, and those are all very, very important. But now what becomes even more important these days is protecting against disease. So let's take a look at office space. In general, that is, the workspace is the target area these days for transmission of COVID-19. And so, but let's take a look at the trends that were going on in the world prior to COVID-19. More and more high density offices, the open workspace, the open office, the telemarketing cubicles, all of these things that we're familiar with, many different companies all working in the same space. And really, one of the companies became really famous for all of this type work and really was a huge, at least marketing success, and certainly to some degree commercial success, is a company like WeWork. And if you've ever visited a WeWork space, they're fascinating, really in a very, very interesting space, but there are a lot of people in a very high density area, a lot of people in close proximity. And the key is there are a lot of people coming from a lot of different directions. These are people from many different companies. There are a lot of visitors coming in and going, a lot of shared office spaces, conference rooms that get used very heavily. And the key with these systems is they almost always have a central HVAC system, because a WeWork space would be in a large office building with a central air conditioning system. And so now everybody's started to have to rethink that because there are issues now in our world that we better understand in regard to indoor air quality. So microbials become a major factor. Microbiology becomes a major factor. Workstations prioritize physical distance and barriers. We're seeing a lot more stuff like this. This is a restaurant rather than an office, but you could see the same type setup would be in one of these WeWork type spaces, so that there are barriers between everyone. And of course, there's a heightened focus on antimicrobial appliances and technologies. The key is there are standards for the protecting workers in HVAC environments, but these are typically hospital standards. And the key is with these hospital standards is they were in place when the hospital was built. And it's very, very, very difficult to retrofit and to apply those same standards that a hospital used when it was being built and retrofit those into a commercial building or other similar space. So let's talk about what ASHRAE is recommending during this pandemic crisis. So taking a look at ASHRAE, which is the world leader in regard to indoor air quality and ventilation. ASHRAE is basically promoting three major areas to focus on. In the areas where there's a central HVAC system, they're recommending to provide as much outside air as possible to flush out aerosolized microbes out of the building. So, of course, we know that the major transmission of COVID-19 is through aerosolized viruses, which are coming out of people's mouths and noses. And if you can bring in more fresh air, then those aerosolized microbes are being pushed out of the building as they're being generated. All right, well, that's a great concept, except all of these buildings are not designed to be able to have huge amounts of outside air. So even today, we were having a discussion with a customer in Europe in a very cold climate in the wintertime. They have a very wonderful weather right now, but in another month, they'll have snow on the ground, and it's not possible for them to be bringing sub-freezing air into the building in high volumes. And so they're preparing themselves now to understand what they will have to do in this condition where they are going to have to shut down their outside air, at least close off more of it, and have more recirculation in the building. The second point that ASHRAE is making recommendations on is the implementation of UV light. So if you're not familiar with it, UV light has a very known beneficial disinfectant capabilities. The frequency and the intensity of the required UV light is a key, and the coverage of the UV light is a key. And there aren't great standards in regard to that. And one of the key points is that commercial HVAC systems are not designed with UV chambers in place. So retrofitting UV isn't always optimal. We also need to understand that there are some downsides of UV, that UV can be dangerous. UV light causes sunburns, cataracts, and such, so it has to be very, very careful to be operated around. And it can also destroy the materials inside an HVAC system. So depending on where it's located, for instance, it can very easily destroy particulate filters. The UV light destroys plastics. Typically, filters are made of plastic materials, plastic fibers of some sort, polyethylene, nylon, etc. And UV light can be dangerous, can be destructive to these, right? And then the third area, which has been a focus for ASHRAE, but is a greater focus now, is the implementation of higher efficiency particulate filters. So these are the three areas which ASHRAE is promoting for people to improve indoor air quality in this age of COVID. So further comments from ASHRAE are specific in regard to the carrier of viruses are aerosols. So just keep in mind that typically a virus may not be floating around on its own. It's probably going to be in some type of aerosol, which is typically a saliva or sputum. The carrier of these viruses can be reduced by high efficiency particulate filtrations. They cannot be eliminated, but the situation can certainly be improved by high efficiency particulate filtration. ASHRAE clearly indicates that HEPA filtration provides the greatest benefit. Without a doubt, where possible, HEPA filtration should be considered. The key is that HEPA filtration is generally impractical for retrofit on most HVAC systems. I think that the general audience here understands that it's typically simply not possible to take a commercial HVAC installation and simply take out the old filters and install HEPA filters. HEPA filters typically have a much higher pressure drop. They require a lower approach velocity, and it's simply not possible. So generally what ASHRAE says is where you're not able to implement HEPA filtration, which is many places, you want to use the highest efficiency possible, preferably a MERV 14 filter using ASHRAE standards, which is equivalent to the European standard F8 or the ISO standard EPM1 filter. So that's the position of ASHRAE in regard to traditional filtration. ASHRAE also does make some comments in regard to alternate filtration technology, and ASHRAE does a good job of really looking at these technologies. There's a lot of technologies that are out there, and they've spent some good time researching these technologies. In general, they make comments on these 4 alternate technologies. So electronic air filters, which generally use the principle of electrostatic precipitation, ultraviolet light, which we really talked about already, the this should be bipolar, not biopolar, bipolar ionization, and ozone. So let's take a look at each of those briefly just to discuss them and see what ASHRAE says in regard to these. So electronic air filters, these include a wide variety of electrically connected air cleaning systems. And when I say electrically connected, not just electrically for a fan to move air through them, but for some electronic removal of particulates. Typically, this is done through electrically charging particles as they enter the airstream, and they are collected on opposite charged plates. So this is electrostatic precipitators, and generally any particle which enters, including viruses and including the aerosols which carry viruses, will accept a charge coming into the system, and that charge will allow those particles to collect on the collection plates. So it's definitely a very secure technology with it. The charged particles give enhanced removal from mechanical air filters. So if typically you would not use electrostatic precipitators only, you would still have the traditional filters after the electrostatic precipitators. And the key is with the electrostatic precipitators, there's a cleaning that's involved that's very critical. And ASHRAE discusses this, the maintenance and the cleanliness of the electrostatic precipitators, quite critical. The wires have to be, it's critical to their statement, this is the actual quote, it's critical to wipe the wires in the electronic precipitator as silicone buildup reduces efficiency. So These electrostatic precipitators are great when they're first installed, and they're great if they're maintained very well. They do definitely have the ability to capture some of these aerosolized particles, but they're certainly not the cure-all, end-all to be able to capture everything. So ultraviolet light, specifically UVC light, and this is a little bit different than just regular UV light. UVC is a certain band of the UV spectrum, but UV light does inactivate viral, bacterial, and fungal organisms, so they're unable to replicate and potentially cause disease. The entire UV spectrum is capable of inactivating microorganisms, but the UVC spectrum, the band called UVC, provides the most germicidal effect. So any UV is helpful, but the UVC band appears to be most helpful with that. And typically UVC just generally is provided by UVGI lamps, which are similar to a quartz tube, or or these are enclosed in a quartz tube, and they're similar to a fluorescent lamp that you might be familiar with. So this is how UVC light is typically generated. So this is an example of UVC here. Here's a specific chamber which has been designed to include UVC in there. UVC induct is a highly recommended technology. Banks of UV light are installed inside HVAC systems or the ductwork coming into the HVAC system. This requires a very high dose of UV light to inactivate microorganisms as they fly past the UV lamps. So there are some formulas about UV doses. You can take a look at the amount of wattage which is required per square area. Typically, airflows are allowed. You're able to work at 500 feet per minute or 2.5 meters per second. In general, you're going to have about a 2-foot or 600 millimeter zone in order for all of this to work. And you're going to need at least a quarter of a second of residence time. That's where that 2 feet is coming from, or 600 millimeters is coming from, in order for this to work. It's not completely instantaneous, it's quick. So the key is, for existing systems, it's very, very difficult to retrofit in this type of sophisticated UV system. These are the systems that hospitals have, laboratories have, very, very advanced system, and certainly highly beneficial, but installing them on the average office building is not typically practical. So ASHRAE also does discuss some point source UV applications as well. So these are UV fixtures that are typically, near ceiling level, or maybe they're hung from a ceiling here. And these UV fixtures are mounted in occupied spaces, typically 7 feet, a little more than 2 meters above. These are, ASHRAE recommends considering these when you want to use UVC light, when you don't have any mechanical ventilation. So maybe you don't have a central HVAC system. Central HVAC systems are popular in large commercial buildings, but very often people are using mini split systems for air conditioning and such. And so this local UVC provides some benefit as well. But taking a look at understanding how many of these you need, and the intensity of it, and the key is you've got to also have air movement in this room in order to get those aerosols into these devices where they can be deactivated inside where the UV chamber is. So you've got to have these supplemental fans when you don't have ventilation in the system. So that would include, ceiling fans and all sorts of other fans in the room to make sure that the aerosols are eventually making their way inside of these UVC devices. So another area for UVC, which has gotten a lot of attention, specifically in hospital environments, is portable UVC. So this is an example of a portable UVC. This is purely for decontamination. It simply cannot be used where in an occupied space. You can see the very clear statement in regard to it, but there are definitely uses for this. These are portable and fully automated units. They might use UVC lamps. So there's also something called a pulse xenon technology. They are specifically set up for pathogens. Generally, you wheel this device into an unoccupied space. Maybe you know that it's been contaminated or it just needs to be decontaminated. And you turn this on, and wherever the UV light hits, it begins to disinfect. So there's bacteria can typically be killed off in about 15 minutes, typically 50 minutes for a lot of other items. So put this in for, let's say, an hour, and you've had a great reduction in it. The key problem with this portable UVC light is it only works where the UV is directly emitted onto the device. So in the corners behind, on the back side of equipment, you know, on the far side of items away from this UVC light, it is not being generally deactivated. And so there are great limitations to this. There are some devices that are robotic type devices that will drive around the room in order to improve that situation. But in general, you're not going to be able to decontaminate the entire room unless you empty the entire room and do that, which is generally impractical when you're talking about decontamination. So another area that ASHRAE specifically addresses, a technology referred to as bipolar ionization. It's also called plasma. There's been many names for this technology. Generally, the people that promote this technology claim it to be a new technology. It is not. It's been around for a very long period of time, and there's a lot of people that have made a lot of money on this technology, but to date, there are very poor information about any benefit to this. And ASHRAE comes out very clearly about this. We'll speak about it, just describe it. So these air cleaners use reactive ions or reactive oxygen species. So they are creating these things. Some of these will actually create ozone or near ozone type particles. So you have to be concerned about that. But generally, an in-depth look by ASHRAE cannot find any convincing peer-reviewed studies in regard to this technology. This is a technology that's been around for decades, and to date, really, there is no good peer-reviewed studies indicating any significant benefit to this product. So I would caution everyone, and ASHRAE also indicates that some of these, not all of them, but some of them emit ozone, which can be dangerous for people. So I'll just mention that ASHRAE is very specific about this technology being, at the very least, unproven. So another technology which is somewhat related to the bipolar technology is ozone technology. There's a number of different ways to generate ozone, but O3 is a very strong oxidizer, and it will definitely disinfect the air and kill viruses and bacteria and fungi when it comes in contact. The key, though, is that ozone is harmful for health and exposure, and should never be used in an occupied space. So if you're talking about disinfecting an area, going back to this space, if you wanted to inject ozone into this space, as long as the ozone wasn't going to get out into neighboring spaces, it could be an effective way for decontamination. Just keep in mind that ozone is highly corrosive, so you can expect metals and such in the environment to corrode to some degree, and that might be acceptable, but it should never be used in any occupied space. And we are always, always surprised to find companies who are promoting ozone in air cleaners, specifically to be used for cleaning the air in occupied spaces. It is not advised in regard to that. You may be creating more health problems than preventing. So I wanted to mention to you that there's some new technology that's available. Only in the past month has this been developed, and PureAir is very proud to announce this technology. Two products which we have by the name of Fiber Shield and MicroAbsorb. These are examples of the products, and we'll give a little bit of detail about these. So Fiber Shield, the first product to discuss, is an antimicrobial fiber that is used in HVAC systems to fight against bacteria and viruses. It has amazing reduction, specifically of bacteria, but also comparably very, very high reduction for viruses and mold, in addition to bacteria. Initial results, which told us how wonderful this technology, indicated 99.9999% reduction of Staphylococcus bacteria, and further testing by independent laboratories indicates that it is highly effective at removal, or deactivation is typically the term that's used in the industry, of viruses, including the SARS-CoV-2 virus, which causes COVID-19. This product is developed in partnership with a very, very notable company called Noble Biomaterials. They are a renowned expert in nanoparticle, nanofiber market. This is the only antimicrobial fabric of its kind in the market. There are some other products which tout to have similar claims, but are not this product and don't have the benefit of this product. We use a proprietary blend of non-woven nanofibers impregnated with sterilized nanoparticles. These are silver ions that are built into the fabric. And this can be incorporated into any particulate filter. So this layer, this is what the layer looks like. And you can see in this electron microscope view the actual nanoparticles, the actual microparticles of silver ions, which have been infused into the fibers. These are not just simply coated onto the fibers, but they are actually built in and extruded in these nanofibers as the material is made. So the nanofiber is part of the fiber. It does not come off. It is very, very structurally just strong, robust, and so covering some of the points here. It's a nylon non-woven nanofiber. It's infused with specific concentrations of Ionic Plus brand silver particle technology. Laboratories have confirmed that the silver that is used in our technology is stronger than the copper or zinc of some other antimicrobial products. So we have upgraded, even though silver is a precious metal, we have upgraded to use silver rather than copper or zinc, which have some benefit to the market, but this has far superior capability than those do. Especially on how we've applied it. So PureAir Filtration is the first and only provider of this fiber technology in the HVAC industry. And I want to present to you some of the really remarkable test results that we have. Specifically, the SARS-CoV-2. Yes, we were able to specifically have this material tested using an ISO standard test for antiviral deactivation on the virus that causes COVID-19 with this result, 99.89% kill rate for it. So really fantastic. We've also tested against other very well-known viruses such as H1N1, bacterias, and fungi as well. This is a very long lifespan, so we expect this filter to have a lifespan of a minimum of a year and probably longer. It has really a extremely robust technology. It is very strong and resistant to any type of wear or crush for it. Generally has a very low cost and of course a very high value. And there are a number of different ways that it can be integrated into existing products. Fiber Shield can be utilized in two different ways. It can be integrated into a layer of a high efficiency particulate filter. Keep in mind that Fiber Shield is not designed for particulate removal. It doesn't have a high efficiency particulate. It is used specifically for antimicrobials, but it can be integrated into a high efficiency particulate filter as a layer in order to provide that antimicrobial benefit. Or it can also be designed to be provided as a second filter after your high efficiency particulate. So in this case, I'm representing a 2-filter system where the first filter would be your high efficiency particulate, and then the second filter would be your Fiber Shield filter. The second product, which we're very excited about releasing, is our MicroAbsorb. MicroAbsorb is based on our gas phase filtration technology. We were able to tweak the ingredients in our adsorbent medias and add into our formulation a couple of substances which allow for our product to be highly antimicrobial. So you might be familiar with our standard formats, but we also offer this as far as a 4mm sphere. We also offer this as a granular media that can be integrated into particulate filters. MicroAbsorb uses permanganate, which is a very, very well-known technology that's been used since the early 1800s. And it's promoted by the World Health Organization for killing microbes, but typically on surfaces, typically for disinfection of surfaces, for cleaning of vegetables and such. But in this case, we have been able to apply that proven permanganate technology onto our porous adsorbent media to create a very effective antimicrobial. So viruses which come in contact with this adsorbent media are killed with a very high efficiency. The results that we have here in this particular result show the H1N1 virus, 99.83% virus inactivation. And that's the terminology that's used for viruses, typically because a virus is questionable on whether it's a living organism. Virus inactivation is the term. But you can see for the H1N1, virus inactivation is 99.83%. If everybody's excited about an N95 mask capturing 95% of large particles, but this product kills 99.83% of viruses that come in contact with it, then really it's a amazing result. And we really just have these results over the past couple of weeks, and we're very excited to share those with you. So Microsorb can be integrated into any place where activated carbon may have been used. So existing customers using activated carbon can switch over to microabsorb to provide antimicrobial benefit, or they can retrofit systems in order to include microabsorb in it. So microabsorb can be included into carbon pleated filters, into trays and cassettes, and into these types of trays as well too. So anywhere generally that you've seen activated carbon, the systems can be easily retrofitted with microabsorb. Activated carbon provides no benefit in regard to microorganisms, and so the customer is very easily able to provide microbial defense with an upgrade to microabsorb. So I want to thank you today for attending our webinar. I hope that it was beneficial to you. ASHRAE has provided a lot of great information, but unfortunately the world is a bit behind in catching up to everything that needs to be done. PureAir is very excited to contribute to the next generation of indoor air quality. I'll mention to you that there is a question and answer panel at the bottom of your screen. If you do have any questions at the moment, you're welcome to type some in and we can answer some for you. I'll call out any questions. And if not, you're certainly welcome in the following days to contact us here. The information, of course, you've got the information from your web link, but you can always reach us at info@pureairfiltration.com or find us on the website at pureairfiltration.com. We do have one question that's come in. Thanks, appreciate that, your interest. Please show me the second slide of the viruses side. No problem. In fact, this will be available for everyone to view. We'll download it. It's being recorded. We'll download it from Zoom and put it on our YouTube page, so everybody will be able to take a look at this as well. So I think that you're looking for this one maybe, or this one maybe. Second slide of the virus slides. How does that? Hopefully that provides what you were looking for. Want to open up, see if there's any further questions? Oh, what is the time scale for the standard tests that the standard tests are carried out? So there is an ISO standard. Typically, it's a 1 hour test, but we have actually commissioned the laboratories to do the test for a shorter period of time. Rob, Rob Hack has been working with our laboratory there. I'll ask him to provide that answer for me. I'm always forgetting the exact amount of time, but it's minutes.
As Kevin said, the standard, international standard is 2 hours, but we've also been using 30 minutes and 1 hour.
So we exceed the world standard in that regard. Also, you said, let's see, is the efficiency of 99.5% for a single use test or carried over multiple tests? So just keep in mind that we're not talking about ASHRAE type removal standards. This is the test of contact of the microbes with the product. But this is for a single use. This is not carried over multiple tests. So this is single contact of the virus with the product. I appreciate that. That's a very good question. Of course, recirculation is great. Not every single virus is going to be captured by the fiber shield or microsorb. Hopefully, a great deal of them will. But recirculation is always, very important. So that if we don't have complete reduction in the first pass through these products, then hopefully we'll catch it on the next. And keep in mind, these products can be used together. Microabsorb can be used in addition to Fiber Shield, where customers are looking to have the absolute best technology available. Vinay has a question: should the surface of the media be always kept very clean in order to have surface contact with the pathogens? So in regard to the Fiber Shield, we do recommend having the Fiber Shield out of not using it as a particulate filter, and having it so that microbes which are passing through the filter come in contact with the Fiber Shield in order to have a longer life. But it doesn't have to be that way. That just the microabsorb has a very, very long life, and if you are going to be implementing this into a high efficiency filter, then you'd probably want to have a pre-filter ahead of it in order to extend the life of your Fiber Shield. The microabsorb has the ability for the permanganate inside of it to rise to the surface of it, and so the microabsorb product does not require any cleaning or anything to that degree. We also have a request to go back to slide 4, so I'll do that real quickly as well. All right. I don't see any further questions coming in. I do appreciate the 7 questions that we got.
Kevin, there are a few other questions.
I'm sorry. Yeah, they just came in. Yeah. How would one know it's time to replace the saturated media? Would the media need to be disposed of as hazardous waste? We don't have any indication at all that either of these would be hazardous waste. We always tell everyone they need to check their local regulations, but there isn't any indication that either of these would be hazardous waste. Knowing when time to change the saturated media for the Fiber Shield, we are generally recommending once a year. So replace the Fiber Shield once a year. In regard to the microabsorb, there's a color change which occurs with the microabsorb. You're able to check the microabsorb and to see if it continues to have its bright purple color, and we can work with you on that. But generally, you're able to indicate it on a color change. Next question is there any specific procedure for disposing of the Fiber Shield and microabsorb? Generally, no. Again, this is coming back to the prior question, so I appreciate the concern. We've never come across a condition where either of these products would have to be disposed of as a hazardous waste. The microbes are deactivated on there, and so there isn't a concern for those. And just from a general chemical or disposability standpoint, neither product is a concern for hazardous chemicals, etc. So recommendation to be put behind an F8 particulate media. Yes, we would. I think it would be probably very good to be behind an F8, but probably ahead of a HEPA filter as well, so that anything that was captured on the HEPA filter could be in contact with the Fiber Shield for deactivation. Any ways of handling the contaminated Fiber Shield filter, like a bag in, back out? Technically, that's not required, though I would certainly say if a customer would want to use a bag in, bag out, like is used in a laboratory, it certainly would be beneficial, have some benefit, but generally we're looking for the implementation of these products in commercial spaces, not specifically in laboratory environments where you're typically going to see a bag in, bag out.
There's one more question in the chat area about what will be the resistance in a typical filter at 500 feet per minute. And by resistance, I'm assuming that means pressure drop across
Correct.
the filter.
we're typically, of course, it depends on the filter configuration, velocity and such, but we're typically expecting about 25 pascals, very minimal, 25 pascals at 2.5 meters per second. I appreciate the question about pressure drop. I should have gotten to that prior. And Vinay is asking if that's Rob's view from his office there as well, so everybody can see Rob has a nice background. Rob, I think you'll have to confess that that's not the view.
Correct. I'm not on the beach right now. Thank you.
All right. Well, thank you very much, everyone. We certainly appreciate your time today. Actually, we have somebody that has a question and raised their hand, so why don't we try that and see if you'd like to ask your question if you didn't ask by chat. Oh, looks like. All right, so I guess maybe we already answered the question in the chat. So I want to thank everybody for joining us. We'll go ahead and end the webinar at the moment. You're certainly welcome to contact us with any questions you have. We're more than happy to work with you. Of course, we're working overtime these days, responding to all the inquiries in regard to the product, but we'll be very happy to get with you as soon as possible. Thank you very much.